Okay, so good morning once again. So in the earlier classes, we have discussed about the definition of energy, classification of energy sources based on various criteria. Okay, why we need non-conventional sources? That is why alternate sources of energy are required for us. So with respect to three different fuels, which are the most popularly consumed across the world. The one is oil, natural gas, and coal. We had discussed the statistics. Okay, we had clearly discussed what has happened in the last 80 to 100 years, how the consumption pattern and production pattern have changed. We have discussed clearly, and based on that, okay, we have derived the importance of non-conventional energy sources. What is the priority of non-conventional energy sources? Why we have to use? Then we, after discussing about world scenario, we took up India's production and reserve scenario. In that, first we discussed about coal, oil, and natural gas, its statistics, then water power. Okay, apart from water power, so total consumption pattern and production pattern across the country with the help of suitable graphs. Then one more important sort of energy that is used is nuclear power. Then finally the miscellaneous. Miscellaneous means various renewable sources like wind, okay, small hydropower plants, biomass and biowaste, solar. Okay, so finally we could come across a conclusion for consumption trends of the primary energy sources across the world. Okay, then after discussing about all the trends, we finally discussed about the advantages, that is merits and demerits of non-conventional energy sources, followed by merits and demerits of conventional energy sources, so that we'll get a clear picture. Okay, so what are the limitations and advantages of various sources of energy? After that, we came to the final topic, that is different alternative sources of energy apart from the conventional sources like fossil fuels, coal, oil, and natural gas. What are the possible alternatives? See, here we have to discuss about 5 different alternatives. Okay, as I told you in the previous class. Okay, out of that, solar, wind, biomass, ocean thermal, wave, and geothermal, we will be detailedly studying in the upcoming modules. So I have not discussed here again, okay, because it takes a lot of time again, and again it will be repetitive. So directly we will move with water power, tar sands and oil shale, and nuclear power. So these three topics we will not be discussing in detail in the syllabus. So I will discuss about those topics here. The one which is mentioned in green are the module 2, 3, 4, 5 in our syllabus. So we will discuss them in detail in those respective modules. Okay. So with respect to each alternative, we have to discuss the mechanism, how it can be used, the first thing. The second thing is what are its advantages and limitations. Okay. So in the earlier class, we just described the definition of water power, and we also discussed about the layout of a hydroelectric power plant, how this water energy can be converted to electric. So here, how this hydroelectric power plant works. See, across a flowing stream of water, okay, there will be a flowing stream of water, a obstruction will be built. Okay, that is called as a dam. So that water gets collected here, okay, like a reservoir. Okay. With respect to the ground level, okay, it has some potential head. That is, potential energy will be there, right? As I told you, a simple example: when you store a 1,000-liter water tank at the first floor, it will be having roughly some amount of head, 78 meters of potential energy. When you switch on the tap with high kinetic energy, it comes out. Okay, that is because of the elevation it has. Okay, so potential energy is usually given by the expression P is equal to rho g h. Okay, it increases with respect to the head or height at which the water is stored. Okay, with respect to ground level, there will be some head, okay, height difference, so that water will have some sort of potential energy. You can see if the water starts flowing at this point, okay, okay, somewhere at this point, the turbine is located at this point. The difference is called as the head. Okay, so it will have some potential head, right? So when the water is let to flow, when you open the gate, it starts flowing through the turbine. When it hits the turbine, in the elements of mechanical engineering, you have studied the concept of turbines. Okay, so just in simple words, I'll tell you, it will be a wheel with certain number of blades. When the water hits the blades, the wheel starts rotating, the turbine starts rotating, so that the shaft of the turbine is connected to a generator. Okay, when it is connected to the generator, power production takes place. Okay, generator produces electricity, then it will be fed to a power grid, right? So now after hitting the turbine, what happens to the water? Through a tail pipe, it comes and joins to the tail water level, that is the groundwater level. Then again it keeps on flowing. Again, this water you can use it for irrigation, okay, again drinking purpose after purifying, etc. So the stream is not disturbed here. Only the flowing water, we built obstruction, store it, then allow it to flow onto a turbine and join it back to stream at some other point, so that water flow keeps on continuing. So this is called as the hydroelectric energy. I'll just explain once again. It is because of the potential energy of the water. Say if I take it as P, it is equal to rho into G into H. What is rho here? Rho is the density of water. Okay, water density is roughly 1000 kg per meter cube. Density of water. G is acceleration due to gravity, 9.81 meter per second square. It is a fixed value. And H is the height, or we usually technically call it as head. Okay, it is called as head. Okay. So if you see that this is the inlet level, get to the pipe, or we call it as the penstock, and this is the inlet level of the turbine. The height is called as the head. Yeah, so this is the head. As this head increases, the energy in the water increases. So you get more potential energy, so that when the turbine will rotate at a higher speed, because water comes at a very high velocity and hits as the potential energy increases, so that you get a better output. Okay, so this is the concept of working of a hydroelectric power plant. Okay, as I told you, if you store a tank over one floor building, okay, the pressure will be different in the taps. If you store it over a multi-story 2 or 3 floors, at the ground floor the pressure you get will be very high. Okay, concept you can imagine here. So this is the concept of working of a hydroelectric power plant. Okay. Now, so the advantages of water power. What are the advantages of this hydroelectric power plant? We have to discuss. We have discussed about the principle of working now, how it works. Now next is the advantages. See, when we observe at that layout, we can clearly find out that we are not burning any fuel. The first and foremost advantage is we are not burning any fuel for the purpose of getting energy. Just moving water, we are building some construction, that is a dam. Okay, we are storing it and we are allowing it to flow over a turbine. No question of any pollution takes place. That is the major advantage of this plant. And also, when you don't burn any fuel, the running cost of the plant will be very, very minimum. Yeah. So when you just look at the layout, this can be imagined at a flash. Okay. Now, one by one, we will discuss what are the major advantages of water power. The first and foremost advantage is water source is available in plenty, and no fuel is required to be burnt to generate the electricity. Okay. So this is the most important point. Okay. The water which is coming out of the turbine can be used for any other purpose. It will not be contaminated. So it is not passing through any chemical, so that we need not have any fear. We can easily use it for irrigation, drinking, and so on. Just it will be stored and passed through a turbine. No question of any chemicals to be added. Right? So no fuel is burnt. The cost will be less, and water is available in plenty. This is the first and foremost advantage. The second advantage is running cost of hydroelectric power plant is less than the thermal and nuclear power plants. So we are just discussing with respect to our country. Most of the plants are thermal and nuclear based. Okay, most of them are thermal based. So if you compare, the running cost is why. If you ask less why, if you ask why, the fuel you feed is almost zero. There is no question of any fuel. Only maintenance cost come into picture. That maintenance cost will be obviously there in thermal power plant also. If it is a hydroelectric or thermal, maintenance cost will be definitely there. Okay. But in a thermal power plant, what happens? If you want to switch on the plant, you have to start feeding the fuel, that is coal. Once you feed the coal, what happens after it burns? There will be harmful gases coming out. Those gases has to be treated and it has to be let out to the atmosphere. Again, that cost will be added. Again, you will get ash as a waste. Okay. So that ash is very much dangerous. If you, it will be of a very small particulate matter like thing. If you just let it to the breeze, okay, it starts flying. It gets mixed with air and starts flying, and it is one of the major contributor of the lung disorders. Okay, so it has to be safely stored and disposed of with proper measures. Okay, so what happens for all this? You have to spend money, so the running cost will be very higher. Whereas if you imagine the concept of a hydroelectric power plant, you are not using any fuel, no contaminants, no harmful gases. So running cost is as minimum as possible. Okay. So this is one of the major advantage. Coming to the third problem, no problem with regards to disposal of ash. As I told you, ash is a major contributor for many disorders. Okay. So in case of thermal power plants, so usually this ash is used in cement industries as a binder. They mix it with cement. So you have to store it in proper containers after sprinkling the water, okay, so that it doesn't fly. Then it has to be packed and it has to be shifted. Just imagine what would be the additional cost. Okay. The problem of emission of polluting gases doesn't exist. Okay. And also hydropower doesn't produce any greenhouse gas. That is obviously known. When you burn coal, coal is the lowest grade of fuel. Okay. Harmful emissions come out. Okay. Then you have to treat whatever treatment is given to that gas. Some amount of pollutants will definitely mix into the atmosphere. So that issue will not be there here. Okay. So coming to the fourth advantage, the plant can be run up and synchronized in few minutes. But in thermal or nuclear power plants, it takes about 2 days to start up and shut down the plant. So what do you mean by this? If you want to run a hydroelectric power plant, see, we have a model of a hydraulic turbine in our fluid lab. So once this lockdown is over, if you come, just I'll demonstrate how easy it is to operate. Just by turning on a valve and switching on the turbine, within minutes, you can start the plant to operate. It starts giving you the output. And whenever you want to stop, if you just shut down the gates, water flow will stop. Obviously, turbine will get shut down. Okay. But in thermal plant, it is not like that. Okay. You have to feed tons together of coal into the grate. Okay. Grate is a place where the fuel is burned. Then you have to supply some oil for initial combustion. Then you have to lit the fire. After firing, it will take 5 to 6 hours, okay, for water to get heated and get converted to steam. So suddenly you cannot take a decision and switch on the plant. It usually takes 24 to 48 hours. Meanwhile, sudden shutdown of the plant is also difficult in case of thermal. See, when the fuel is burning, you can just imagine it is not easy to shut down it suddenly. It takes again 12 to 18 hours. Okay. But hydroelectric is not like that. It is very easy to operate. Okay. Next advantage is the plant is highly reliable and its maintenance and operation costs are relatively low. How if you ask maintenance and operation cost? See, maintenance and operation cost increases when number of components in the system are very high. If you consider thermal power plant, as I told you, you should have some mechanism to treat the gas. There a set of components will be increased. Then you should have a mechanism to collect the ash and treat it and pack it. Their number of components increases. So obviously maintenance cost also goes up. But here in hydroelectric, there are no such mechanisms. Only it's a single layout plant. So maintenance cost will be very low. Coming to the next point, that is the sixth point. Hydroelectric power plant has greater life and it can easily last for 50 years. Or first and foremost issue is the capital cost is very high. As I told you, so you need to build a dam. To build that, one second. Okay. So you need to build a dam. So before that, it requires huge amount of area and the surroundings of that dam also should be completely vacated. Okay. Then you have to invest on the construction. Okay. It will take minimum of 8 to 10 years for completely building the plant and making it operational. Okay. So good amount of money you have to invest for a quite longer time. Okay, the gestation period of hydropower projects is very large. It will take 10 to 15 years, as I discussed. This is the major issue. But whereas in other power plants, the issue is not so, right? So the third point is power generation is dependent on the quantity of water available. This is the major drawback, okay, which will vary from season to season. During rainy season, where the stream of water flow is very good, no issues of any power. So power flow will be continuous. Will have good production. During summer season, when there is no rain, the issues of continuous generation of power will be raised. Okay. The alternate method is, okay, you have to store a good amount of water for the summer season. If you want to do that, the dam size should be very large. Initial cost will be very more. This is one of the major drawback. Plants are often far away from the load center and requires long transmission lines to deliver power. This is a common thing. Why? Because see, you cannot plan this plant as per your requirement. Okay, so you cannot plan. We will build a hydroelectric plant very nearer to an industrial area. so that without a huge transmission line, I can just directly supply the power within a short. That is not possible. Wherever you have a stream of water flow, you have to set up the plant there. From there, you have to bring the power to the required site. So little bit longer transmission lines are required, so that initial investment will be more and the cost of transmission will be increased, and also the losses will be more. The transmission losses will be more. And the last point is large hydroelectric power plants completely disturb the ecology, okay, by way of deforestation. Say for example, you have to relocate good amount of people, cut all the trees, green vegetation you have to remove from there, you have to uproot the people, load on one part of the land increases, sometime it may lead to landsliding or earthquake, etc. Certain issues will be there. So these are some of the limitations of water power. Please make a note of it. Please make a note. I'll give you 2 minutes time. Next, we will move to the next alternative, okay, that is nuclear power. So nuclear energy is the energy in the nucleus of an atom, either by fission or fusion reaction. Okay, you can get out the heat energy. Fission is the process of splitting a heavy nucleus into smaller ones. Okay, and fusion is the process of joining lighter nuclei to form a larger one. In the process, okay, energy is released, which can be used to convert water to steam and drive a turbine, so that you will get the electricity. I hope you have studied in the +2 or so. Okay, I will not describe it in detail. Nuclear fission and fusion are the two modes of reaction. Use of nuclear power. So what are the advantages and limitations of this nuclear power is the question. Nuclear is more economical compared to thermal, okay, where coal is filed as a far away. So fuel cost is lesser, obviously. There is no problem of fuel transportation, storage and handling, etc. So obviously coal, you have to shift it in terms of millions of tons. So every day hundreds of trucks has to move to the thermal power plant. So comparatively size wise, these fuel containers will be very small, transportation will be less. Okay. Manpower required for the operation is less, therefore cost of operation is reduced. Nuclear plant occupies less space compared to hydro or thermal power plants, wherein you have to uproot a good amount of people, occupy larger area. Such problems will be not there in nuclear power plant. They are compact plants. The capital cost, okay, will be just setting up the reactor, piping, storage, etc. So it will be relatively less as when you compare to hydroelectric, also investment will be less. So these are some of the advantages of nuclear power. So what would be the limitations? The first is danger of nuclear radiation. Hope you are all aware. Also, what are all the issues? Problems of disposing the radioactive waste materials. This is always debatable. Okay, usually the experts in that field say it's not a huge, very objectionable issue. So it can be packed in containers and it can be buried underneath the sea. Okay, so over a period of time they become inactive. Until then, it should not be exposed to any living organisms. That is the concept. But it is not so easy. Yeah. Problem of disposing the radioactive waste material is always there. So if you are exposed to those radioactive waves, okay, it can cause serious health hazards. Okay, and it can make genetic disorders also. Okay, one of the objectionable point. It has to be operated at full load through at a good efficiency. Okay, it cannot operate. See, we were discussing about load. Hydroelectric, you want lesser power, just shut down the gate, it decreases. Such facilities will not be there here. Okay, so the last limitation is you have to go for a huge size plant with a very high production capacity. You cannot plan for a smaller one, as the cost of small plants will be very high, right? So these are some of the advantages and limitations of nuclear power. Please make a note.